Hello everyone. Let's now troubleshoot CPU spikes in SQL Server. As you might know me from previous sessions, I always try to explain troubleshooting with internal architecture of SQL Server. Why? Because you should fully understand what is happening in the background while you are troubleshooting. For example, when you face CPU spike, I don't want you to just log in and kill high CPU consuming queries, but understand how and what way this spike has happened internally and what should be done in the future to prevent the same. For this, you should understand scheduling in Windows and SQL Server, and also you should have good understanding of SQL OS. Therefore, I prepared these sessions as recommended sessions for you before starting this session. If you have time, please go through them. But if you don't have time and want to jump into troubleshooting, or you have good knowledge of these topics, you can skip these sessions. So you detected high CPU usage. What's the next step? In the first step, we should verify that SQL Server is causing high spike or not. For this, we can utilize Task Manager. If SQL Server Windows NT 64-bit is very high, around 90%, you should go to the next step. If non-SQL process is causing high CPU, you should contact your Windows team or team responsible for this process. Let me explain you how this happens in the background. As also mentioned in my previous sessions, when you run SQL Server queries, task is created for this query and this task is scheduled inside SQL OS and run on Windows CPU. SQL OS consists of worker pool, runnable queue, IO request queue, and a waiter list. Also, Windows CPU has running, ready, and waiting queues. If the thread is in SQL OS, this thread is referred as in user mode. If the thread is in OS CPU, this thread is referred as in privileged mode. Suppose this select query task was running in CPU and CPU usage was low, around 10%. Suddenly, some kind of system process with high priority entered to ready queue. Right at the time, system OS puts this SQL Server process back to ready queue and starts this high priority system task. This task was very much CPU intensive and started to take a lot of CPU time. As a result, CPU utilization increases to 90%. As you can see, SQL Server is not causing any CPU spike, but some sudden started system process is causing that, right? Furthermore, as you can see, due to this system process, select query is not given enough CPU time, and as a result, you started also to see performance issues in SQL Server. If you find SQL Server process is causing spike, we should switch to next step where we check kernel time, privileged time, and user time. In this step, you should collect the metrics from performance monitor like process privileged time, process SQL Server user time, process SQL Server processor time. If process SQL Server user time divided by number of CPU is constantly higher, SQL Server is causing high CPU. If process SQL Server privilege time divided by number of CPU is constantly higher, your antivirus software, other drivers, or another OS component on the computer is contributing to high CPU usage. You should work with your system administrator to analyze the root cause of this behavior. In this case, you had better to uninstall any third-party driver or antivirus software in your system. Let me explain what I mean by this. Suppose there is no task. Therefore, privilege time and user time is 0. Suddenly, one task came and assigned it to a worker. As a result, user time increased to 5 because there is only one task in user mode. Now, to run this task has been submitted to kernel CPU and it changed to privileged mode. As a result, privileged mode also became 5%. This is normal condition. However, sometimes CPU spends more time to process SQL Server tasks than expected. For example, instead of 5%, the CPU might spend around 90-95%. This often happens due to some antivirus or third-party drivers installed in Windows. Because these drivers add extra processing, checking, filtering, which increases execution time and makes CPU more busy. If you observe such kind of big discrepancy, big difference between user time and privileged time, you should contact your Windows team and make them check third-party drivers. Please note that just disabling does not work here. You should completely uninstall these drivers and check performance. What about if user time is also high, privilege time is also high? In this case, you should switch to next step. If user time is high, this means that SQL Server is causing CPU spike. In this case, we should check inefficient queries which caused or causing spike, the load at the time, and compile times. Suppose one long-running select query and fast-finishing select query tasks have been submitted to SQL Server. Then SQL Server puts these queries in runnable queue and submits first comer to CPU. Let's say this time long-running query is first comer. Then this query is run. In the meantime, other queries should wait in runnable queue as only one query is submitted to a CPU per scheduler, okay? But as this is long-running query, this query will use all the allocated CPU time but could not finish during this period. As a result, it preempts voluntarily and goes back to runnable queue, then again waits for its turn. After this, another task starts, and since it is fast finishing, it completes quickly. Then SQL Server again submits this long-running query. We can summarize the lifecycle of these long-running query tasks as follows. As you can see, if your query spends a lot of time on CPU, this causes high CPU time. In the later live demo section, I will show you how to detect this kind of long-running queries and troubleshoot. Basically, in this situation, mostly fine-tuning of your query is needed. Let's talk about high load. This happens when SQL Server submits many tasks to CPU and makes it very busy. To troubleshoot this kind of situations, we should first measure number of executions at the time of the issue and find cause of why you experience so much sudden load. If this is expected behavior, you should add more CPU. Okay, now we are clear about steps. Let's resolve some real-time high CPU issues based on these steps. I want to share examples for ongoing and past high CPU issues where you might need RCA. Let's get started. Okay, let's start with the first case. This is SQL Server VM where you spotted high CPU. Let's start from step 1. Before blaming SQL Server, we should first investigate whether SQL Server is causing high CPU. For this, we check Task Manager. As you can see, currently CPU utilization is very high, but as you can see, SQL Server is not consuming, but process called CPU stress is taking CPU. I'm running this CPU stress tool to reproduce the issue, so therefore it is expected. So, as non-SQL Server process is causing the issue here, we stop at the first step and contact engineers who is responsible for this application or process. This has been first case. Now let's switch to another case. This is another server where high CPU usage is being observed. Let's check Task Manager. As you can see, this time SQL Server is causing the issue. Therefore, we will switch to next step 2. We run this command in command prompt quickly. As you can see, we are facing high user time compared to privileged time. This means that spike is coming from SQL Server itself. Privileged time is lower. Therefore, we can rule out any possibility of third-party tools or filter drivers. Now let's go to step 3. If the SQL Server process is causing high CPU usage, by far the most common reason is SQL Server queries that perform table or index scan. We can run this query and define how much SQL queries are causing spike. As you can see, on average, SQL Server query is causing the spike. Okay, let's define what is the cause, long-running query or high load. To define this, we run this query. As you can see, we have only one query with high CPU time. Wait time is about 250,000, while CPU time is twice as big as wait time. This means we are mainly running and making CPU busy. Since we have only one query with high CPU time, from here we can conclude that the cause is inefficient query with high execution time. This query should be investigated. I will show you how to investigate a long-running query in my next sessions. Let's focus to define cause of high CPU in this session. So we found inefficient query caused spike this time. Now let's see another case. Here again, we can see high CPU usage with SQL Server consuming high CPU. We again confirm that user time is high compared to privileged time, which means SQL Server causing high spike. Let's connect with SSMS to check long-running queries. Interesting. We cannot connect even to SQL Server. High CPU is not allowing us to create session, and we face an error. Let's connect as dedicated admin. Okay, now we can connect. As separate thread is always available for dedicated admin, you can sometimes connect with dedicated admin while usual connections does not work. Okay, but do not think that this is always. Now let's try to investigate which query or queries are causing the issue. We run this query. As you can see, this time not only one but different sessions with the same query are causing the spike. You can see all of them are in a runnable queue. This can be an example of high load. CPU time is not so big, but high number of queries are putting pressure on CPU. We can confirm login names, client application information, and request times with this query. This was a session level analysis. Let's go more down and check queries at request level. You can now see a list of all the requests, some of them in suspended, some of them in runnable states. We can see suspended requests are waiting for latch. When we investigate SQL Server statements, we can observe that all of these queries are the same, meaning application is sending a lot of queries and we are experiencing unusual high load. Let's check also scheduler level information. Here you can see this environment has two CPU and there are schedulers created in parallel for each CPU. We already talked about this, right? Currently, each scheduler is holding this amount of tasks. This is nearly equal to the above requests if you can't. There might be some difference because we cannot get on-time information always. Out of this, you can see this amount is in runnable queue. So what does this info give me in general? I have high number of tasks currently putting pressure on CPU. This number is around between 650 and 700. These tasks are evenly distributed among these two CPU. This is unexpected load for me because I usually experience only 5 or 4 tasks at a time. I should check my application team for what is causing this spike, why we are experiencing this sudden spike now. If my application team says that application became, for example, famous and this load now became expected, I should add more CPU so that this load is distributed among more CPU and tasks count per CPU should decrease. Okay? Higher load, higher resources, right? This has been the third case where CPU spike has been caused by high load. Let's see another case. Here, you can see again SQL Server is consuming a lot of CPU. Let's check who is culprit actually here. Okay, as you can see, SQL Server user time is very high. This means that, again, query is causing the issue. Now, let's try to connect with SSMS. As you can see, we cannot even connect with admin now. In this case, we cannot access and check what is happening. High CPU is not allowing us to do anything. Therefore, to mitigate the issue, we restart SQL Server. Okay? Unfortunately, when SQL Server is restarted, many in-memory data is updated and not become available anymore. But we need to find what caused the issue, right? In this case, we need root cause analysis. So our helper becomes here system health event logs. Save it in log folder. Let's check what we can find here. For this, we load these logs to SSMS by merging them all. You wait a little until loading finishes. Here you can see many connection related errors which happened due to high CPU. Let's group the logs by name first. Then I firstly pay attention to wait info, which gives me information about any resource contention. Oh, okay. You can see here many source worker related waits. I started to sense an issue. Let's go to the issue time. As you can see, source worker wait was being recorded at the time also. This means that there was not enough worker in worker pool to run the requests. Because of this also, we were not able to log into the server. Let's check also SP Server Diagnostics component result. I add data and component names as columns. Let's sort by component name. Then I go to query processing component. Here you can find maximum number of workers available for query processing. Next one is how many worker threads are needed for the current load. Then you can also see number of completed tasks within 5-minute interval and any pending tasks now. Let's slowly go down to issue timing. Okay, here you can see sudden increase in the number of tasks from around 1,500 to around 6,500. Interesting. This caused high demand for workers, you can see. The number of workers needed is exceeding number of maximum workers available, right? This is causing worker deficiency and connection timeout also. Therefore, we couldn't connect. Okay? So what we can conclude from here? There was significantly increased number of tasks from around 1,500 to around 6,500. This caused CPU spike and worker thread exhaustion. Now we should check with the application team why this load was observed. Okay, let's conclude this session with another approach. There are some cases where CPU spike is unpredictable and intermittent. You don't know when it will happen again. It happened in different times before. You need root cause analysis now. What can be done in this case? There are different approaches, but you should select an approach which is less CPU intensive, because there was a high CPU is expected, so your log collection should not take so much CPU. In this case, I suggest collecting two logs. One is performance monitor logs and one is extended event logs. We create extended event by using this query in SQL Server. Here, I'm collecting any errors, execution plan, batch statement completion, and starting events. Not all of them is necessary, but sometimes you might need further information, just in case therefore I'm collecting more detailed information. You should just adjust log place also here if you want to try this in your environment. I'm sharing this comment with you. Let's create now. After creating, you will have the event here. You just need to start. Next, we create performance logs by using this command. You can use AI UI, but running the command is much faster with just one command. After creating it, Do not forget to start. Now we are ready for any occurrence of the issue. Let's keep this running. About the size of the files, do not worry. We are setting data file size limits in both logs. If this limit is reached, the logs keep updating. Let's now wait until the issue reoccurs. Okay, we had alerts that CPU utilization increased to around 60, 70, 50%. Let's now stop our log collection. First, we stop extended event, then we stop perform logs. First, I want to start investigating perform. It will enable us to know the issue timing also. For this, I go to log location and open the logs. First, let's check CPU utilization and who was consuming how much, right? You can see every CPU utilization with red lines here, okay? And utilization per CPU with green and blue lines. Okay, issue timing is around here. Now, let's check SQL Server CPU utilization at this timing to prove that SQL Server was responsible. Oh, okay. You can see high user time SQL Server CPU utilization at this exact time. We have two CPUs. If we divide this CPU utilization by SQL Server by 2, we can conclude that SQL Server was utilizing around 50-60% at the timing. So SQL Server was the main process which was causing high CPU. So SQL's good. So we checked first and second steps now, right? We confirmed like there was high CPU. We confirmed that SQL Server was responsible. Let's now investigate why SQL Server caused the spike. For this, we go to extended event logs. Issue start time is around 8:10, as you might remember here. Let's check SQL statements completed at the time. First, I group by name. Then I filter the logs by making CPU time more than 0. Okay, now let's check execution plan profiles. First, I enable important columns like execution plan, CPU time, overall duration, scheduler ID, client information, and finally, SQL text we should investigate. Now, let's go to issue timing. Then, we should check any unusual high CPU timing around that period. These are system queries, okay? Oh, I found one unusual CPU utilization, very big CPU timing. You can investigate this query now, okay? Execution plan is already available. This seems inefficient query which needs fine-tuning. Let's check other occurrences. You can see other occurrence at issue timing. The same query, okay? So the same session. So it seems that we are passing inefficient query from the same session. So this is the issue where inefficient query caused high CPU. Let's check also how many tasks were there to confirm whether there was any high load. For this, I check system health check logs and can see the number of tasks at that time was usual around 1000. So there is no load issue, but only inefficient query which needs to be fine-tuned. So what to conclude? We experienced high CPU and we found SQL Server was causing it with perform logs, right? Then we investigated individual queries with extended event. okay, and found inefficient query. I hope you found this session useful. Thank you.